Hello students, today's agenda is to check homework. We'll be graphing horizontal trigonometric transformations and you will be able to work on 10.11. Today students will be able to graph horizontal trigonometric transformation. And if you recall from 10.10, we worked with the transformations of the amplitude, which is vertical stretches and compresses, and moving the midline up or down because it's vertical shift. Okay, but this video will focus only on the horizontal stretches and compressions and the phase shift, which is a horizontal shift. Okay, so that's what we're going to be focusing on. To find, this has to do with the period. For sine and cosine, usually a period is 2 pi, and to find the new period, what we do is divide those 2 pi by b, and we'll figure out, you'll see when we get to the examples. And for C, it's the opposite. That's why it's negative C. If it's negative, you will go positive. And if it's positive, you will go to the negatives. The shift will be towards the negatives. Okay, again, you'll see once we get to the examples, and that's going to make more sense. Okay, so number 1. In here it says f of x equals cosine of x plus pi over 2. What this means is that you're going to do a horizontal shift of pi over 2. So you're going to be moving every single point, but now remember that it's negative c, so it's just the opposite of this. Some people prefer to do what they do is get everything that is in the parentheses plus pi over 2 and equal it to 0. Then they subtract pi over 2 from both sides. We cancel that, and so x is equal to negative pi over 2. So that's my horizontal shift, is going to the negatives pi over 2 spaces. We already learned how to graph cosine in 10.7, but it's just for 0 it's a 1, for pi over 2 is a 0, pi is negative 1, 3/2 of pi is at 0, and 2 pi is a 1. So it's 1, 0, negative 1, 0, positive 1. Okay, and those are the points that we're going to be shifting pi over 2 spaces to the left. Okay, so as you can see, these are broken into half of pi, and so what I'm gonna do is that this point is just gonna go right there, 1/2 pi to the left. Okay, this is at 0, it goes only one space to the left. This goes right there, this goes right there, and this goes right there. As you can see, I'm also using different colors so that we can mother graph and then the new graph. Okay, again, the other thing that that made my life easier is to go from the lowest point and from the highest point and graph grabbing towards the 0. It's like a bell. And so that's my new transformation, moving it to the left. Okay, from that same lesson, 10.7, we learned how to graph the mother graph of sine. See that I don't have the measurements in here. Let me show you how to fill it out super fast. The first one I skip, and then I put pi, skip 2 pi, skip 3 pi. The other ones is by 1/2, 2/2, 3/2, but these are simplified. So it's just 1/2 of pi. And then I skip to 1, 3, 5, 7, etc. So it's the odd numbers. Okay, that's how you can easily fill it out. So this one is going to be negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay, And we're not gonna need that. Oh, the other thing that I wanted to say is that I'm just graphing one period. The curve will repeat infinitely, okay? But for the next one, I'm gonna focus just on one period. So sine starts at 0, 0. It goes up 1, 0, negative 1, 0. And that's one period, okay? Again, I just graph the curve to make it easier. Round and then like that. Okay, so that's one period right there of sine. But now this is saying go to the right. Remember that if this is negative, it goes to the positives. If it's positive, it will go to the negatives. Since it's negative, it's going to go to the right. And how many spaces will it go? It will go a whole pi. Not half a pi like we did in the first one, but a whole pi. So it's, if you're noticing here, whole pi is 2, these units that we put down. Okay, so the other way is to just put x minus pi equals 0. I add pi to both sides. This cancels and x equals pi. Since it's positive, it means that it's to the right, okay? And so this point will now go here. This point will go right here. I'm moving it 1, 2. This point right here will go 1, 2. And this one will go 1, 2, right there. I forgot this one. This point on pi from this yellow curve, it goes 1, 2 right there. Again, I go from the top down. So my curves can be nice and curved. Okay, so that's my transformation of the whole sine, one period of it, moving it. We'll go on and on and on. Remember, this is just one period, but it's actually infinitely going on both directions. So with number 2 and number 1, we are subtracting something from the x. It's to the right of x inside of the parentheses. In here, we're adding something to x inside of the parentheses. That's when we're doing the shift to the left or to the right, okay? But for the next one, we're not adding or subtracting something from x. It's not on the right side. It's on the left, and it's multiplication. Okay, when we have that, that's going to be a horizontal. Horizontal. And it can be a stretch or a compression. When it's multiplication on the left of x, it's going to be stretch or compression, okay? Again, for sine, it starts at 0. And then you just go up, 0, down, up. Okay? Right there, negative 1. The more we do them, the more we'll remember. And so in here, to find the new period, this is something that you might want to write. To find the period, you need to divide the 2 pi, which is the actual period that it takes for sine, divided by b. This will be b. Okay, this is your b, which is always multiplying, is the coefficient of x inside of the parentheses. And so 2 pi divided by pi, we cancel this and we get 2. So the new period will take 2. And you can see that there are some markings in here because now we're going to be using whole numbers because the period is 2, not in terms of radians, which is pi. Okay, so let me explain how I did that. And 2 cannot be directly graphed with the radians in here, so we have to find where the 2 would be. And I put some markings in here, but let me explain it. This y-axis is right here, which is a 0. And then I have pi. We're using 4 units or 4 squares for that pi. That means that that's equal to the 4. It's equals to 3.14. I cannot put 1, 2, 3 here because it would mean that this is 0.14 and it doesn't make sense. What I did was to divide it so that we have 1 and a little bit more, because we're dividing, let's say that that's 0.14 and it should be less than that, but we have to divide this part among the other 3 parts in here. So it's 1 and a little bit more that's given to this, and a little bit more is given to the second one, and a little bit more in here. So 1 would be around there, 2 is around there, and 3 is around there, which is close to pi, but it's not exactly on pi. Okay, so that's what these lines mean. So 1 is about there, and it's not exact, you know, but that's going to help us to guide us. This is 3. And so what this says is that my new period of sine is going to be 2, meaning that this curve, instead of taking 2 pi in radians, it will take only 2 spaces. Okay, so what does that mean? We have these points. This is going to stay in the same place, and this point will go to 2, and it's on 0, so you just bring it here. What does that mean? That since this is half of the sine of one cycle of sine, this is half, so half of 2 is 1. This point is going to go here, and this is in the middle of pi, right? Pi and 0. This is halfway of those 2. That means that this point is going to be half of those 2 points, which is right here. So half of 1 is 1/2, and it stays at 1. Okay, so that point is going to be somewhere around here. It's not exactly half of 1 square, but a little to the right. And then that means that this point will be between 1 and 2, which is around there. And now I'm able to graph it. And that's my new sine. And so again, what this compression, it's a compression, right? Because it's compressing, says that now what took 2 pi takes only 2. Okay, for number 4, again, it's on the left of x, inside of the parentheses, that's b. And so that's going to help us find our new period. The period is 2 pi over b, so it's going to be 2 pi over b is 1/2 of pi. Remember that 1/2 of pi is the same as pi divided by 2. So we're just going to put here pi divided by 2. We put this over 1 so that we can divide by using the shoe horse. So 2 pi times 2 is 4 pi. And 1 times pi is pi. The pi cancels because pi divided by pi is 1, and you just get that the new period is going to be 4. Okay, so that means that, well, that I need to draw the mother graph first. And so for cosine, sine starts at 0, but cosine starts at 1. Then it goes down to 0, then -1, then 0, then +1. Whoops. Okay, so that's your cosine. Now what this is saying is this whole thing has to fit into 4. And again, pi is 3.14, so it's a little bit more than that. And so let's do what we did in the previous one. So that's about 1. 2 is about there. 3 is about there. And so that means that 4 will be somewhere around there. And so the easiest way to do it is that this stays in its place, but this point will go right there to the 4. Okay, this point goes right there to the 4. This point is half of the original cosine, and half of our new graph is going to be at 2. Half of 4 is 2, so this point will move right here. And this one will be half of 4 and 2, right? Because this is half of right there. So that means that that's going to be at 3. And then this one will be half of 2 and 0. So it's going to be at 1. Again, that's just to guide us. And we start graphing. And so that's our cosine of 1/2 pi of x. And here I already have the mother graph. To find the new period, it's 2 pi divided by b. b is 1/4. So we divide 2 pi by 1/4. Because it's a fraction, we put it over 1. And then remember that we multiply the outer and then the inner values. So 2 pi times 4 is 8 pi. 1 times 1. 1 times 1 is 1. And so it's 8 pi divided by 1 is just 8 pi. What that means is that this sine, which usually is 2 pi, will stretch to be at 8 pi. That's why I made this longer graph. And so, what does that mean? This stays at 0, 0. If this is going to be at 8 pi, then this, which is halfway, whoops, I shouldn't have marked that. This that is halfway is going to be half of 8 pi, which is at 4. This is usually half of this section, so it's going to be in the middle of these two. So half of that is 2 pi 1. That's not a point, okay? And this one below at negative, and this -1 will be, since it was in the middle of these two, it's going to be in the middle of these two, which is at 6 pi -1. And so that's going to be our graph. This is going to be a little trickier to graph, but it's something like this. Remember that sine goes up to the middle, down to the middle, okay? Oh, wow. Okay, and then this one right here. Whew. So that's our stretch, our horizontal stretch. Okay, number 6, again, the mother graph is cosine. And for the new graph, it's going to be f of x equals cosine of 4x. So again, for the period, what we need to do is to divide 2 pi by b. b is 4. So it's 2 pi divided by 4. These are not able to divide, but we can simplify. So 2 divided by 2 and 4 divided by 2. And so the new answer will be pi. 4 divided by 2 is 2. Because the 2 just cancel. 2 divided by 2 is 1, but we don't put the 1 as a coefficient. So we'll now compress this original graph to fit into pi over 2. That's what this means, okay? And so this point stays exactly where it is. This point here is going to be at pi over 2, so right here. This is half of that, so if this is pi over 2 and 0, so this will be half of that. And then this one will be in the middle of these two, so in the middle of these two, so it's about there. And the other one around there, okay? So again, we graph from the bottom up, from the bottom up, and from top to the bottom. So that's my new compressed cosine function, okay? For the last two, we're not only going to have one transformation, but two horizontal transformations. You're going to have a shift and also a compression or a stretch, both horizontal. If it's inside of the parentheses, we say that they're horizontal transformations. Okay, so for the original, in here, you're going to have cosine. It's going to be +1, 0, -1, 0, +1. Okay, and we connect them. And the first thing that you want to do is to compress it. So this is B. That's the easiest way for me. You might find it, because you can do whichever you want first, but to me it's easier to compress it and then do the shift. Okay, so again, for the new period, that is not going to be 2 pi, it's going to be 2 pi. Remember that for the period is 2 pi divided by B. Let me rewrite it. And B is pi. So 2 pi divided by 2 by pi. Pi cancels and you get 2. So the period is 2 units. Again, we have to do the division where we equal the pi to 3.14. So 1, 2, 3. So 1, 2, 3. The new period is 2. So now my graph will be, this is right here, it stays. This one goes to 2. This is half of that, so it goes to 1 because 1 is half of 2. And then this one is half of these 2 points, so it would mean half of these 2 points, so somewhere around there. And this point will go in the middle of, because it's in the middle of these 2 points, so it's in the middle of these 2 points, so around there. And now I can graph it in here. But remember that that's just the compression. We still need to shift it. And to shift it, you can just say, oh, opposite of this divided by this, but it's easier to just write it, okay? So pi of pi x plus 4 pi equals 0. That's how you find the horizontal shift. Just putting this equals to 0 and start solving for x. So minus 4 pi minus 4 pi. This cancels and you get pi x equals negative 4 pi. Divide by pi. This cancels and you get, the work is going to be, well, negative. This cancels as well and you get negative 4. So it's going to go 4 spaces to the left. And so that's going to get tricky because now we have to go on this direction, but with four spaces. So it's going to be, again, it's 1 and a little bit more for 1. Then that will be around there for 2, negative 1, negative 2, negative 3 will be around here, and negative 4 will be somewhere around here, okay? And I made the mistake of writing that in there because it looks like our graph is going to be somewhere in there. So let me use a different color. Pause the video, write that down because I'm gonna go right on top of that. And so my new graph, this point will go, it's at 0, right? For x, it's at 0, so it's going to go these many spaces to the left. These many spaces to the left. So 0 is going to be at 1, 2, 3, negative 4. Oh my goodness, this is really overlapping. Okay, this point is aligned to 2, so 1, 2, 3, 4. So it's right there. this point is aligned to 1. So 1, 2, 3, 4. It's right there. And so these ones are just in the middle of that, but it's in between then -2 and -3, right? -2 and -3, so somewhere around there. And for the other ones, between -3 and -4, so somewhere around there. So again, these are not perfect, and I'm so sorry that I'm overlapping the work in here. I didn't see this coming. I didn't think it through, but that's our new graph with 2 transformations. It's a horizontal shift to the negatives, and this is a compression. Okay, you can see it there still. I apologize about that. And the last one, we have 2 different transformations again. Let me draw the mother graph. So for sine, it's 0, 1, 0, -1, 0. Okay, and I just connect those points. The first thing that we want to do is the new period. So for the new period, remember that you have to divide 2 pi by b, and b is right there. It's a 2. These cancel and you get pi. So my new period is pi. That means that my new graph will fit into the pi. Okay, so what does that mean? This point stays where it is. This is not a 2 pi, it's half of that. It's a pi right there. This point that was there is half of that, so it's going to be a pi over 2. And so this is half of the middle, so it's going to be in the middle of these 2 points right there. This point that was in the middle of the middle and the last point, now is right there, the last point, so this goes here. Okay, so I'm just compressing the first and the last point together before that. Then I get the middle one and put it there, and then below is in the middle of those, it's right there, and this one is in the middle of these 2. Okay, I connect them. Yikes. So something like this, but that's just the compression. The final has to be moved or shifted, and you do it by equaling the whole thing by 0. So 2x plus pi equals 0. I subtract pi from both sides. Pi cancels and you get 2x equals -pi. Finally, we divide by 2. And so x is equals to -pi over 2. That means that you're going to shift it pi over 2 to the left because it's negative. Moving it to the left, pi over 2 spaces. Okay, so this is easy because it's divided into halves of pi, but it's going to the left. So this point goes here. So 1. This point, which is in the middle, goes here. This point will go at 0. This point goes here, and this goes here. So basically, the pi over 2 is 2 spaces. You're just moving everything 2 spaces. 1, 2. 1, 2. This one is 1, 2. This one is 1, 2. And this one is 1, 2. Okay, and I just connect the points. Remember, I have a hill on the top and I have a valley underneath. So the final product, the final transformation, it's going to be the blue one. Okay, that's what we're looking for after moving. And you can actually erase this one if you do it with pencil, the first ones, and then just do the final one with a color. That will be perfect. Or you can just like dotted lines, okay? And know that the blue is the final product after changing the period and changing the shift, okay? Both transformations. So that's it for horizontal transformations. In 10.12, we're going to do a mix of transformations where we'll have both vertical and horizontal transformations. For now, you can do 10.11, but before that, if you can just give us a thumbs up, subscribe, look at the playlist for this whole unit, and this is the next video, and have fun.